Okay, good morning. Today's topic is how to build decision tree models. Uh, this decision tree is the actually for the linear regression. Mostly we will use for the regression model. Logistic regression also will use for the classification mostly. But coming to the decision tree, this is the popular machine learning algorithm. It will use for both models, whether it is the regression model, whether it is the classification model. So by using this decision tree, we can build regression model and classification model. Uh, you people already know this is a supervised learning algorithm. So we will have dependent variable. If there is a two types, supervised learning and unsupervised learning. Supervised learning means for this data, we are providing input data with output data. So that is the dependent variable. Here we have the independent variable and dependent variable. Coming to the unsupervised learning, it have only independent variables. There is no dependent variable available for the to build a model. That type of data is unsupervised learning. So while conducting clustering session, I already told you hierarchical structure. Hierarchical structure means uh, what it did first, it will take the root feature which have the high information to split. Then after it will go for the till each node become as a cluster. Same hierarchical structure of decisions and conditions from the input features to make the predictions. In same concept we will use for the decision trees also. Here we need to know some methods how to we calculate root features, what are the leaves. There are the some types, that is the Guinea impurity, and another one is the entropy. For example, actually these two are used for the classification trees. The data set D with k class. Here data set we have the k classes, that might be k means it might be 2, 3, 4, 5, whatever it may be. And n data points. N data points and the number of records. How many records does we have? Here we will calculate the probability, where pi is the probability. The probability of instance belongs to class A. For example, in Guinea impurity, what will do? Guinea of D equal 1 minus sigma I to K. I to K means here K is the number of classes. So that means we are calculate the probability for each class. What we are doing here? We are calculating probability for each class, and then after we are summing that one. Sigma means sum of the Pi. I is the nothing but probability of the instance belongs to class I. That means number of class. How many classes are there? For example, let's assume we have the three classes. That means we will get the three probabilities. We will get
Um,
three probabilities. Hello?
Ma'am, will use this Guinea impurity only for classification, not for that other that is
Not
linear.
classification trees means uh, decision decision tree for regression model, for the classification model. For both models, it will do some classification. For example, here classification means we have the 10 features. Out of the 10 features, it will take one is the root feature. That is the, for example, let's come to the OS regression. Uh, um, sorry, OS nebula formula. There we have the operating system versions.
Mhm.
Whether these are under maintained or not supported Windows Server, what will say it is the replatform. Whether it is the new version, but we need to updated version, but we need to change 2016 to 2019, we'll say it is the rehost. So
Mhm.
this is the main parameter compared to other one to classify whether it is a rehost replatform. This is the main parameter. Like that, out of the 10 features, which is the main feature? That is the which feature have the high information gain. We take first, that is the root feature. Then after what we'll do, how decision actually it is the classification of the trees, not classification of the classification problem. Trees means we'll say, don't think it this is used for the classification trees means uh, for example, let's take decision tree. Actually, if we have the independent features like this, it will take the one of the independent feature is the base one. Then after it will check whether it is the, for example, this independent feature have the two classes, whether it is the yes and no, like this one. So
So,
if it is yes, it will go for the one way. If it is the no, it go for the another way. Then after under no, there is the what is the status, marital status. It will check marital status, single, married or not, like this. But uh, this is the classification of the tree. How it classified tree. Then after how it will predict as a regression model or classification model. But here, this is the problem. Why we are using what is the Gini impurity? What is the use of the entropy? That is, for example, let's take here we have the refund, marital status, and third one is taxable income. Okay, out
yeah,
of these three, which one will become root? Which, how do we calculate that one? Actually, I am here. I have taken refund is the root, that is the first starting feature I have taken as a root. But you says, ma'am, why are you taking refund? I want to take marital status. Some other Lakshmi or some other one says, no ma'am, I want to take taxable income. But we can't take which one is the root, some of the independent random independent variable as the root. If we have taken like that, whenever we build model, whenever for example for the same data set, if we are building 10 or 20 models, 10 or 20 models gives a different output. So
mhm,
we need to follow some specific rule to classify this tree.
yes,
That rule, that is the classification trees here. That rule is nothing but how we are forming that rule is we this one is the Gini impurity, another one is the entropy. What is
yeah,
the
ma'am.
use or yes, that's if you don't know these concept, you don't know how they are splitting this one. That's why first I want to say about the what is Gini, how we are calculating Gini index, how we are calculating entropy.
Yeah, but one thing means how we are able to judge that this particular feature will we select as a root.
That's what I want to say. If you know that these, that's why I'm saying these formulas. First,
Okay, to
you
do.
know about this Gini, what is Gini impurity, what is entropy, how we are calculating. Then after, we'll say by using these Gini index and entropy, how we are selecting which one is the this.
Root.
I am in now. I am in second slide. I did not completed this entire thing. Then, if I
Yes.
completed this entire thing, then you will understand.
Okay.
Okay. See, Guinea impurity for this is the why we are subtracting from one means the probability of the all classes is always one. For example, we have the three classes. That means 100 records. 30 records class 0, 30 records class 2, remaining 40 records class 3. What is the probability for the class 0? 30 records. That 30 records. That means 0.3. For the class 2, again 30 records. So 0.3. For the class 3, 40 records. That means 0.4. So total probability of the all classes, sum of the all probabilities are 1.
Mm,
What is this? So that's why we are subtracting 1 from these probabilities. That's why Gini impurity ranges between 0 to 1. It won't go less than 0. It won't go more than 1. That means,
yes.
yes, where 0 indicates a pure node. All data points belong to same class. For example, here we are we have taken 1 minus this one. For example, let's take if the probability, if the probability, we already know the probability of all classes are 0. If whenever we calculating this probability for each class based on the one feature, you have take a refund feature. By
Okay.
the refund feature, you can calculate the what is the probability of the class 1, class 2, class 3. If the probability of class 1, class 2, class 3 for that refund feature is 1, that means the refund feature have the guys, please mute. Yeah. That refund feature have the full information about the dependent variable. That's why the probability of that feature to that classification is the that class is the 0, 1. 1 minus 1 means that feature, that refund feature have the complete information about the dependent variable. Complete information about the dependent variable. If it is 1, That means the probability of class is very less. That means by using that refund feature, we can't able to classify whether it is that which class or other class. I will explain clearly. See, let's see here, where 0 indicates a pure node. That means all data points belong to the same class. That means let's take this is the one. See, if yes, no, no, yes. For the no, we have the two yeses, two no's. For this one, for example, here we have the six no's, seven no's. Okay, cheat, no, we have the two. If this is the classification, binary classification, it have the yes or no, two classes. Let's observe the no. If it have the no, no's seven. Let's check how many no's are refund have. How many no's? Four no's and three yes, three yeses. By let's take, if shall we able to say refund, if the refund is no, automatically the cheat will goes to the no. We are able to say that one? No, we can't
Okay.
say. Why? Because here there are some yes who are refund yes, or no cheat. He is not cheating. So by using this refund, we are able to say, for example, seven out of seven, we are able to by refund we are have the no's four. That means four by seven. What is the probability? Total possibles are seven. How many is that? Is the four. Let's take the yes. There is a chance negative correlation. That is the, if refund is yes, shall we able to say he won't cheat? That is the 3 by 7. What is the probability? 3 by 7 plus 4 by 7.
Okay.
If we are by using refund, damn surely we are able to say that is the no cheat. If we have that information from the refund, what how much probability we will get? We will get probability 1 for the each class. How, for example, here there are dependent variable have the no classes 7. If refund have the same no rs 7, no rs for the each no, not both no and yes, whether it is a yes, whether it is a no. What is the probability? Here total possible outcomes are 7. Here, whether let's assume there is a refund yes for the all no. How many possibilities we will get? 7. 7 by 7 means 1 probability. That means 1 minus 1. How much we will get? 0. 0 means by using that independent variable, we can classify or we can regression dependent variable without any help of the other. So now you can understand here, if by use there might be no cheat. If refund is no, there might be no cheat. If we are able to say 100%, that means what we will get? That means wherever here no presented in dependent class. For example, let's take the, we have the 50,000 no records, 25,000 yes records. Let's take, you can consider 50,000 no records, 25,000 yes records. For the 50,000 no records, we have the refund yes. Refund yes. For the remaining 25,000 yes records, refund have the no. There is no misclassification. So through this refund only, that means what is the probability for the refund yes, refund no? That is the, for the how many cheats we have? The 50,000. So in denominator, total possible outcomes 50. How many yeses are there for the each no? That is the 50. That means 50 by 50, that is the 1. So whenever if we are able to say by using this refund variable 100% whether it is cheat or no, that means we will get the probability 1. Whenever we apply that probability value here, what will get? 1 minus 1, that is the 0 indicates the pure node. That means all data points belongs to same class. Okay,
Okay.
all data types belongs to same class. If 1 indicates the impure node, data points are evenly distributed across classes. That means, for example, let's say here, yes and no, both are presented in each and yes and no here, dependent variable. Whenever you have take only no cheat no variable, there might be a chance to be refund yes and no. Whenever you have filter only yes variable from the cheat, you will get the yes or no from the refund. That means that is the impure. How much impure means whether it is the one means it doesn't have at least 5% information about the dependent variable. Okay, due to that, based on by using refund, we can't say whether it is the cheat or no. At least 5% confidence with 5% constant confidence. So
Yes, ma'am.
what we need to check? We need to calculate Gini for the each feature. We need to calculate Gini for the each feature. We need to check whether it is the pure node or impure node. Which node is high purity? Then that node will become root node.
Okay, so high purity, it means the value which is near to almost one. It will
Yes,
be
high purity
notable.
means near to zero. Zero. High impurity means near to one.
Okay,
Yeah.
so it
So
means pure node means high purity, right?
yes, zero means 1 minus 1. So here the total
Yes.
class for whole probability 1. By using this feature, we are also able to get probability 1. That means good classification. 1 minus
Mhm.
1, 0.
Okay.
Actually, the independent variable, dependent variable class is 0. We are able to, by using refund variable, we are able to calculate probability for the 0 for class 1. That means, uh, yes, we'll say one thing. We'll go for the classification model. What is the how logistic regression says whether it is the class 0 or class 1 by using probability. How it uh, ca- how it say based on the probability whether it class 0, class 1. Let's take class 0 is the class 0, class 1. We have taken 0.5 is the threshold. Yes, if the whenever we calculate probability, it gives the 0.3 for the probability of probability 0.7 plus. So 0.7 is more than 0.5. So class 1 get the high probability, class 0 get the less probability. That's why what we say this data point belongs to class 1. Okay,
Yes.
let's take whenever we calculate the probability, we will have the 70% confidence. Probability 7 means 70% confident. We are saying this is the uh, it belongs to class 1. Let's take we have the another data point. It gives the probability of class 0 is 0. Probability of class 1 is 1. That means it's purely related to the class 1. There is no assumptions. There is no um, information loss. 100% we are saying this is belongs to class 1. How? The probability of 1. That means the variable which gives the probability 1, that means we are classifying correctly. Is it right? We are classifying correctly. For whenever we calculate the probability 1, so we get the probability 1. How we are calculating Gini? 1 minus 1. That means 0. That means that is the good classification. That's
Okay.
why Gini index is the 0. 0 is the good classification. And pure node, if for example, for the probability class 0, the probability is class 0. If we are saying the data point is class 0, why? Because due to some other problems, yes, whatever the independent variable what we are using, what it says, it gives the probability 1 for the class 0, probability 0 for the class 1. Actually, this data point belongs to class 1, but this independent variable doesn't have the any information about the dependent variable. So what I'm saying, this independent variable doesn't have any information about the dependent variable. That's why whether the new data point is related to the class 1. But whenever we calculate the probability, this independent variable gives the high probability. That is the class 0, it gives the probability 1. For the class 1, it gives the probability 0. That means entirely 100% misclassification. What will happen? Actually, we are expecting here what we are getting. Actually, this is the class 1, but we are getting the probability 0. What will get Gini 1 minus 0? That means Gini D equal 1. That is that purely impure node, impurity that doesn't have the any information about the dependent variable. Are you guys clear, or shall I explain? Shall I repeat it again?
No, ma'am, it's fine.
Yes. So what we are thinking actually, zero is the less, that means that this is the impurity. One is the good value, higher value compared to zero. That's why we take it as the. But coming to the Guinea here, whenever the mathematical, we won't get that type of intuition. Zero is less than, one is greater than, 100 is the greater, like that. We need to, what is the concept we are using behind this one. Here 0 indicates the purity, 1 indicates the impurity. Here what we are doing, class 1, this is the probability. We are calculating the by using probability for the independent variable. If that independent variable also gives the probability 1, that means what we are expecting same, that is it gives, that means 1 minus 1 0. That is the good classification. But for this class, what we are expecting 1, but it gives the 0 0.2, 0 0.3, or 0 is the probability. That means we are expecting 1, but it is giving very less probability. That means that value is near to 1. That means that is the misclassification, that is the impurity.
Okay.
Okay. The goal is to find the split, minimize the weighted Guinea impurity. At this will lead the more homogeneous subsets. Homogeneous means it takes, for example, first it takes the refund. Here it takes the refund. Then after it go, whenever it know, then it actually by using this refund we are able to say these two only. If refund is no, but we can't say whether it is no and yes, at that time we'll take other independent variable help to decide whether this cheat is no or yes. Okay, uh, that's what here we are doing. Coming to the entropy. Here entropy, let's consider the same data set is the D, K classes and data points. Here also we will calculate the probability. Here what we are doing, probability 1 minus sigma of the probability for the each and every class. Here also we are doing sigma of probability log to probability. You people know the how we are log values. Actually log values we can't calculate through the formulas. We have the lot of functions, algorithms to calculate the log. So instead of doing this one, here it calculate the sigma of the probability log probability. Here also the range of uh, entropy ranges between 0 to log 2 k. Log 2 k. Why? Because log 2 value, based on the log 2 value, here our entropy will be depends. Same, where 0 indicates the pure node and log 2 indicates the completely impure node. That means all classes are equally distributed. For the Guinea entropy, both whenever the Guinea are 0 or the entropy is 0, that is the pure node. That means all points belongs to same class. But if whenever we go for the 1 or log 2 indicates that completely impure node, that means all classes are equally distributed.
Okay.
Let's take, we can use association rules to identify the what factors are associated with the cheating. We are able to say whether it is the refund yes, matrix status single and taxable income greater than 125, then it is the 20 no. By using based on the refund and matter status, we are able to identify whether it is cheat or no. No, we can't
Yes.
we can't take that type of rules. That means what I am saying is logical rules. If we want to build any Python script, what we'll do? Based on the rules, if condition based, we will take some threshold values. Whether this is greater than, it will go that side. It will go, is the less than, it will come this side.
Yes.
But that type of rules, conditions we can't apply for the this type of models, classification models. For that purpose, what we do, let's take splitting attributes. First, here, these two are the categorical variables, refund and marital status. Why? Because there is no priority for yes and no. There might be no difference between yes and no. We will give same priority for both. Yeah, that's why this is the these two are classification models, and this one is the numerous. Sorry, numerically continuous variable. Let's take let's see, we are splitting attributes like this. What we hear, refund is no, marital status is married, no. Shall we able to say this one? Exactly. Assign cheat to no. Let's take coming to this side. It is sorry, I'm saying clearly. Whether refund is no, marital status is married, then is the no. Refund is no, marital status is a single or divorced, and income tax greater than 80 lakhs, 80k. That means yes, income tax 80k. If the income tax is the less than 80k, that is the no. What will happen if they provide income tax exactly 80k? If income tax is greater than the actually marital status is the married, but income tax is exactly 80k. Shall we able to say whether it is the cheap no or yes?
No, ma'am. Think.
No. So that's what I'm saying. If then rules associated in the feature space, if we are doing like this, any rules, we can't say whether it is the if data points have the some other value. If data point have the new value, then we can't say. So greedily divide binary split of the feature space into distinct, no overlapping regions. Without overlapping like this, we need to split our attributes in which way? Distinct way, instead of binary split. That means whether it is yes, whether it is no. No, don't split like binary split like this. Here we are saying whether it is yes or no. Here also we are checking whether it is greater than 80k, whether it is the less than 80k. So don't check like that. Just you can space into distinct. If we are splitting this like binary split, we won't say whenever new data point comes, we can't say whether it is the class 0 or class 1. So we need to split into distinct. That means, for example, here continuous you have that 10 or 20 variations. We need to split our income tax and in that variations. That many distinct variations we need to split to say whether it is the no or yes. Here, every observation mapped to a leaf node assigned to be labeled most commonly occurring in that leaf classification. That means here we are classifying, for example, let's take 25 to 120k, 70k, 100k. This is the no. 95k, yes. 85k, yes. 90k, yes. See, from this one, let's observe 95, 85, 90. These three are the yes. What will, based on this one, what will do? So 85 to 95. Greater than or equal to 85, less than or equal to 95 is the less. The remainings are no. If let's say we have the yes for the 50k, at that time we need to distinct the other one, not in like this binary. We need to distinct the other one, that is the less than or equal to 50 are the yes. So we need how do this one will show through the graph also. So we what I'm saying here, people don't use binary split. We need to how many variations presented in the in, uh, current independent variable. We need to split that many distinct splits. Then only we will able to say classify correctly at the end. How we are saying for this one? Let's take here. What here we did? We did only binary class for the tax. Let's take, we have the income tax less than 61k. Less than 61k. Yes, okay. No, it's not. But coming to the years, we have the lot of people 20 to 40. Out of the 20 to 40, 20 to 30 are class 1, 30 to 35 are class 0, again 35 to 40 class 1, again 40 to 45 class 0. If classes are based on the age, if classes are going variation, we are observing lot of variation based on the age. At the time, by using the whether greater than 27 s, that is the cheat s. If the Greater than 27, that is the sheet. No, no. We need to how many class variations present in that independent variable is. We need to split is that many times. Here first we have taken less than 27 is the yes, that is the blue color. If the greater than 27, again we will differentiate whether it is less than 38 or greater than 38. If the less than 38, that is the yellow. Greater than 38, again blue. If we have the any variation, again we will split. Did you understand, people? Let's take the same example. Here you have taken one, which is the smallest value, 60. First you can take greater than 60 is the no. Greater than 60 is the no. But again you can put another condition, that is greater than 85. 60 to 85, that is the no. Again you can split 85 greater than 85. You can give whether it is the less than 85, no. If whether it is the greater than or equal to 85, yes. Again you can split that same taxable income 65 to 100. 100 is the next point. If whether it is the less than 100, that means yes. Why? Because 85 to 100 all are S's. Greater than 100, no. So we need to split distinct splits, not only binary split. We need to split distinct like this one till we achieve, based on this tree, we need to achieve correct classification. See, first he had splitted like this. Then after he observed lot of blues here. Compare. Actually, this is the blue classification. This is the yellow classification. But here there are lot of blues presented in the yellow classification. What it did? It did again two splits. So it will compare first this one, then after this one, then after this one. Then only it will decide whether it is related to the class blue or class yellow. Did you understand? In linear regression, what we'll do? We'll do only one hyperline, that is the linear line. Whether it is below the linear line, that is the one class. Whether it is the above the linear line, that is the another class. Let's take the sigmoid function. What we'll do? This one, logistic regression. Yes. Whether the probability is here, that is the class 1. Whether the probability is here, that is the class 0. If is there any values presented in, it will be this logistic regression, linear regression, those will be helpful for the when the data is linear. What we do if the data is non-linear? Actually, we are able to build machine learning models on the linear data. We can't work this linear data, non-linear data. That's why you can provide linear data. We can't say like that to the client, customer. Whatever data he presented, whether it is he gave, whether it is the linear or non-linear, we need to build our machine learning model to classify correctly. In that point, our decision tree, SVM, random forest, these machine learning models comes into the industry. So if it will split lot of times till we are able to exactly classify the classes correctly, at least 90 to 95%. If let's take, if we have taken only single binary split, there may lot of misclassification. If we are splitting distinct splits, then we are able to classify, at least compared to binary classification, we are able to achieve some more accuracy. The feature space contains all data. Divide regions contain homogeneous data subsets. Region boundaries define regions. That homogeneous means, for example, here you can take this example only here. 85 to 1995. All are S. That means these are the homogeneous. These all points are belongs to class S. Again 100, 125, 120k. So these are belongs to 1. So we need to find that type of a homogeneous data subsets. Which data points are the data points which are come to the yellow class, the data points which are come to the blue class. Root contains all data, leaves contain homogeneous data subsets. For example, whenever we have taken income as 60k, it have the all data, whether it is yes or no. But coming to these leaf nodes, it have the branches to classify the correct class. What we call, actually this is the root node. Which one we used as the root node? That is the first independent variable. That is the root. Remaining all are leaves. Remaining all are leaves for that root node.
Okay.
Here, I already told you about the Gini index entropy. This is the classification error. This is the classification error. So by using these three parameters, we will split the our model. Let's please don't forget how we are calculating classification error. Let's see here 1 minus max of pj. That p is nothing but here probability. So entire thing depends on the probability calculation. What we'll do? We'll do 1. You know, for the independent variable, how many classes are there? The probability of all classes, sum of the all classes probability is always 1. So 1 minus max probability. How much max probability we are getting by using this independent variable? So we'll do, based on that we will calculate the classification error. How much error we will get by using this independent variable. If we are classify dependent variable by using this independent variable, what is the classification error? Let's say instead of taking all variables, we need to check classify the classification or regression predict through the regression model. We need to classify, sorry, we need to predict, we need to classify using each and every independent variable separately. Till now, what we are doing, we have selected some informative variables 10 or 20. We will use all variables to build a model. But what here we did, first we will calculate the probability to identify the which independent variable have the high information about the dependent variable. For that purpose, we will calculate the probability for each one. We will select what is the classification error. For example, let's say 1 minus max p is a 0. 0, that means R, let's take T1. This is the T1, I T1. Here blue, all are green. This is the green one. This is the green class. All are greens. That means total possible outcomes are 3. How many correctly predicted as a 3? That is the 3. That means max of probability 3 by 3 is the here 0 by 3. 0 by 3 means 0. So the max probability is what we will get, max of 1 and 0. Which value is the max value? Whether it is a 3 by 3 is the 1, 0 by 3 is the 0. Which one is the max? 1. 1 minus 1, 0. That means it is the pure classification, pure node. Let's take the T2 also have the pure node. Let's take the T3. Means all data points are distributed in this same class. Here, let's take the probability. Probability of the green is the total outcomes are 3. That's why denominator I placed with 3. What is the probability of the green? That is the 2 by 3. What is the probability of red? That is the 1 by 3. 2 by 3 means 0.66. 1 by 3 means 0.33. What we have taken is the max. Which one is max? This one, 0.66. Compared to this 0.33, 0.66 is the max value. So 1 minus 0.66 means 0.33. Here there might be chance of 0.3% of the error. Guys, I think now you people get good explanation what I said in Gini index. Why I am saying 0 is the pure node, 1 is the impure node. Why? Because this is the classification 1. If the all data points predicted correctly, what will get? Here also probability, what will get? 1. Why? Because here it classifies very correctly. So 1 minus max p is the 1, that is the 0. So if we get the 0 is 0, that indicates that is the pure classification. There is no impurity. Whenever we get some value, that means that much impurity presented in that independent variable. Here T1 is one variable, T2 is one variable, T3 is one variable. Predictor means independent variable. Predictor means
Yes.
independent variable related to the one class. We are observing only one class. So how we calculate this one, we'll use for the example. Let's take, we have the three classes. We have taken one data set. In the data set, dependent variable have the three classes. Out of three classes, we have calculated for class 1. Let's take the one independent variable. Class 1 that have the total, how many records does it have? 200 records. Out of the 200 records, 60 records are related to the class 1. 100 records are related to the class 2. 40 records are related to the class 3. Depends on this independent variable. This independent variable actually class, this independent variable, for example, it have the marital status, single, divorced, married, like that. But class 1, maybe that may be chance to be out of 60, there may be chance 40 are married, 10 are single, 10 are divorced. But we don't know how many single, how many married, how many divorced are presented in this 60. But we have the total 60 records related to the class 1. Okay. Based on the how many single, how many married, how many divorced, we will calculate the probability. We will calculate the probability. That is the 0.3. Out in the class 2, there are the 100 data points. But we don't know how many single, how many that one. But we are calculating 100 by 200, that is the 1 by 2, 0.5. Probability is 0.5. The number of records belongs to class 3, that is the 40. 40 by 200, that is 1 by 5, that is the 0.2%. Probability is 0.2. Whenever we calculate probability, the sum of all classes is always 1, that is the 1. But for the class, what we are calculating here, classification error. What is the formula for the classification error? 1 minus max of the probability. Here we have taken out of these three probability, which one is the max? 0.5. So here we calculated the classification error. 1 minus 0.5 is the 0.5. Okay, this is for this independent variable. Then after go for the another. Here also we have the classification 1 0, classification 2 100 records, classification 3 40 records, total 150 records. Again we calculate the probability. 10 by 15, that is the 0.07. 100 by 150, that is the 2 by 3, that means 0.66. 40 by 150, 40 by 150, that is 0.27. For the classification, what we'll do? 1 minus max of the probability. What is the max value here? Out of these three probabilities, which is the max value? 0.66. So 1 minus 0.66 is the 0.33. Same calculation here also. Here total are 50. All 50 are belongs to the class 1. That means probability 1 for the class 1, probability 0 for the both class 2. Why? Because 0 by 50, 0 by 50 is the 0. So 1 minus 1, that is the 0. So what we able to say, if that point is there any point available, that is the definitely the data point is belongs to class 1. So we will get this one. Let's calculate the how we calculating by using sigma value. Yes, we need to calculate each and every independent variable. That's why 150 by 200 total, the base one, the root variable have the 200 points. That's why this one 150 by 200 into classification error 0.33, 50 by this one 200 into what is the year of classification error? 0. So total classification error is 0.25. That is the information gain here. So what is this? This is the binary classification. So what is the probability? What is the threshold? 0.5. That's why 0.5, sorry, this is the 0.5, 0.5 minus what we will get through these two, 0.25. So 0.5 minus 0.25 is the 0.25. That is the information gain.
Okay.
Same thing, I already told you. Guinea. For the Guinea, what is the formula? For the Guinea, probability of 1 minus probability 2 plus probability 2 of 1 minus probability 1. This is the formula for the Guinea. Same formula we will apply here. First here probability 0.5, probability 0.5. So what we'll do? 1 minus max probability g. That is the classification error rate. Sorry, I have given another two examples. Did you people understand how we did classification error rate here?
Yes, ma'am.
Yeah. So same thing. Let's say I have taken two more examples. For the two more examples, this is the 0.5, 0.5. So max is the always automatically 0.5. 1 minus max 0.5, that is the 0.5. Again, here we calculate the probability. So here max is the 0.75. That's why 1 minus 75, that is the 0.25. Here again, we reversed the data points. That's why we get the 0.25, 0.75. Again, here max value is the 0.75. That is the 1 minus 0.75. That is 0.25. What we'll do here, we have the 400. Here we have the 400. In this first, we have the total 80 records, 800 records. Based on this condition, what we'll do, we splitted these 800 records into 400, 400. So again, we need to classify this by using this 400, this 400. So 400 by 800, 400 by 800 into what is the here classification error? 0.25 plus here again 400 by 800 into what is the classification error here? 0.25. This value, if we want to calculate the classification error of entire tree, that is the 0.5 minus this value, that is the 0.25. Let's take here we have the another example. Here we have classified into 800 records into 400, 400. But here we classified 800 records into, based on this condition, here is the 600, here is the 200. Again, we calculated the probabilities. Here max probability is 0.67. So 1 minus 0.67 is the 0.33. Say here max is the 1. That means 1 minus 1 is the 0. So here how much we get in first split? 0.5. So 0.5 minus how many records does it have? 600 by 800. Total outcomes 800. Out of the 800, in this part we have only 600. So 600 by 800 into what is the classification error rate? 0.33. 0.33. Here 200 by 800 into what is the classification error rate? 0. By calculating this, by simplifying this one, we get the 0.25. Okay. This is how we are checking impurity based on the classification rate. Go for the Gini index. Here what is the formula? Sigma of probability minus 1 minus probability. Sigma of 1 minus probability. Here we calculate the 0.5, 0.5. By substituting these values into this formula, we get the 0.5 is the final value. Here we have the 800 records. Again, in the same example, in the first split, we split it as the 400 records into one side, 400 records into one side. Again, we calculated the Gini value by using this formula. This is the 0.38. This is the 0.38. Again, we calculate the what is the impurity. Here we are calculating the impurity. Here, what is the value in the first attribute? We get 0.50. 0.50 minus 400 by 800 into this Gini value. This Gini value, that is the 0.38. Here also we got the Gini value 0.38. That is the here. What is the impurity? 0.12. Just here classification, Gini and entropy. We are changing the algorithms. What is the formula? Mathematically, equations we are changing. But what we are calculating? Impurity. What is the purity and impurity of this particular split? Same process we applied here.
Okay.
Guys, Is it clear? If you have any doubts, you can ask.
No,
So
ma'am.
why actually probability? Probability, based on the probability, we will calculate whether it is the impure or pure. That's why again here we are calculating the what is the probability of these two. What is the probability of this class? Here these data points. Those are the 600 by what is the total possible total records that are those are the 800. 600 by 800 into what is the Gini index of this particular split. That is what we are doing here. Okay. Same calculation for the cross entropy. Here the formulas will be changed. The mathematical algorithm what we are using is the change. So probability of log of 1 by Pj. Same application, we will calculate the probability. We will substitute the probability values into this formula. We will get the sum entropy of these two splits. This is the entropy of this split. This is the entropy of these two nodes. So then after here what I got 1. 1 minus 400 by 800 records into what is the entropy here 0.81 0.81 400 by 800 into what is the entropy here 0.81 again. So total impurity is 0.19. Just like same. Here also we calculated the 800. So entropy is 1. Here we calculated the entropy for this split based on this 600 records. That is the 0.91. Here it is again 0. Why? Because all records are belongs to one class. So we will get 0 for the other class. Again same. We calculated the impurity. Here it is the 0.3175. Then let's see how these values will be useful. The measure of impurity. We have the 3 different algorithms to identify the impurity of the split. What is the difference between these 3? Let's take. Determine information gain, determine split choice. Measure of the impurity is information gain. Information gain is nothing but how much information does that independent variable have about the dependent variable. See, for the binary classification, if it is a binary classification, the threshold value is always 0.5. Yes, whether we have the range always 0 to 1. If it is a binary classification, the threshold value is the 0.5. That is the maximum. All measures reach at maximum 0.5.
Yes.
Okay. Till here it will be 0.5. See here, all points will reach maxima at 0.5. All measures are symmetrical around the maxima. All measures means symmetrical means the curve. Let's observe this curve. This is exactly reflection of this one. This curve is exact reflection of this one. At the same time, this curve is exact reflection of this one. This one, this one, this one. 3. You can observe these 3. These are symmetrical. Symmetrical means the image of these are same in the both sides. So all measures are symmetrical around the maxima. If it is the binary classification at the maxima, this is the symmetrical. Both differ in how they evaluate impurity. How they, let's take, we'll say this one also through the example. So now you people able to understand how classification rate measures, how Gini index measure, how to entropy measure. Then let's check what will happen by using these measures individually. Let's take, we have the one data set, ID is income, family, CC average and personal loan. This is the dependent variable. Let us do information gain per split on ID. Let's do information gain for this split ID. ID is the unique ID. So we won't repeat identification value for the two members. It is the unique ID. Let's check the gain for this unique ID and this CC average. Is ID is the root attribute. We need to check whether ID is root attribute or not. An attribute with many more states is likely have less variation in each state, so it will always give better information gain. So we need to normalize it something like information gain for state. For example, let's take a attribute with many more states is likely have less variation in each state. If we have the different states, the variation within the state is very less. Why? Because the people who are living in that state, they will follow their lifestyle is maybe similar, right? Their lifestyle may be similar compared to one country, other country. If we compare our country with other country, US, the lifestyle of the India is all the people lifestyles are similar. At least they are very near. Someone's who are someone, for example, we have the different states, but there might be little bit difference, but the difference is not much. But compared to India, US, the lifestyles are very high. That's what here saying. Many more states is likely to have less variation in each state. In each state, the variation is very less. So we need to normalize to go something like information gain. Normalization is the common technique. If you want to apply PCA, if you want to apply clustering, if you want to apply feature selection, before going to build machine learning model, it is better to normalize the data. So you can remember this thing. That's it. I won't repeat same concept for each and every model. Let's calculate the information content. Entropy. Here, this is the formula of the entropy. Yes, did you remember? And what is the entropy formula? Sigma of Pj log 1 by Pj. That is the same formula here we have used. Let's calculate the information content of the ID. It has 13 states. That means 13 records. Here, what are the total records? 13 records. That's why that they are saying 30 states. So the information content is 1 by 13. 13 means 13 values are different. Why I have taken here 13? That is 13 values are different. Is there any similar value? Did you observe any ID repeated?
No.
No. So total classes in this ID, that is the 13. So 1 minus 1 by 13 in multiplication log of 1 by 13 comma 2 into 13 is the 3.7. Let's come to the CC average. How many classes does it have? 3. CC average is 3. If you can apply that one, information content of CC average is 1.33. Due to this, what did you observe? Let's calculate the gain ratio by using what? Actually, the information gain is the main parameter for the decision tree. First, we will calculate the information gain for the each and every attribute. Which attribute get the high information gain value will take, that is the root node. Why? Because that independent variable have the high information about the data set and high information about the dependent variable. That's why we treated that attribute as the root. So how do we calculate that gain ratio? Let's take the information gain by information content. How do we calculate? Information gain by information content. Yes. Let by applying these values, by applying these values in this formula, what is the gain ratio for the ID? That is the 0.27. Gain ratio for the CCVC, that is the 0.37. 0.37.
Yes.
Let's see what will happen. Here, actually, if we calculate only information content, what will get a high value? ID. We need to give high priority for the ID value compared to CC average. Yes? Why? Because this is the high value. But due to this one, due to this high variation, Gini index will fail. Gini index will fails. To overcome this problem, we will use gain ratio. Gain ratio. Gain ratio. For that gain ratio, what we'll do? In information gain by information content. This is the formula. Whenever we normalize like this one, that's why I'm saying here, we need to normalize the split. How do we normalize like this one? By calculating the gain ratio. That is information gain by in information content. Then only we will able to identify which attribute have the high priority. Which attribute have the high priority based on the gain ratio. Let's take the initially I said this decision trees is useful for the classification problem and regression problem. But classification problem means that is the dependent variable is the categorical variable. Regression means that the dependent variable is the continuous variable, continuous numerical variable. Let's take how many potential split points possible determine the computational complexity. For example, here the value is uh, here the bad and good. This is the problem. Root value. Here we have the one attribute that is the categorical attribute cylinders. Whether it is the cylinders 3, whether the cylinders 4, 5, 6 or 8. This is the classification problem. So what we'll do? How many bads, how many goods are here? Here good means red color, bad means blue color. How many records does cylinder 3 have the good records and bad records? How many records does cylinder belongs to good and bad? Like this, we will do the split. Here, we won't do any binary split, whether for the cylinder greater than 5, that is the one split, cylinder less than 5, that is the one split. We won't take binary split. How many classes does it have? We will do that many splits. We will do that many split. For this one only have the good data points. This cylinder 4 have the good data point. That means whenever the new data point comes, first we check whether does it have the cylinder 4, 5, 6, 7, 6 or 8. Sorry, there is no 7. What we'll do, whether that cylinder have the 4, will predict that is the good. Whether that cylinder have 0, 5, 6, 8, then we'll predict bad. Let's take the 3 examples. Cylinder 4, cylinder 6, cylinder 8. From the 4, most of the data points are good. That's why we will say this is the good. From the 6, most of the data points are bad. That's why we will say it is the bad. From the 8 also, most of the data points are bad. That's why we will predict bad. In here, cylinder 5 also, there is the only one data point that is related to the bad. Here we predicted bad. Coming to the cylinder 3. Here there is no data point for bad, no data point for the good. But it says it predicting it as a bad. Why? Why? Because this is the misclassification by using this cylinder. Why? Because here cylinder 4 only belongs to the good. Remaining all are belongs to the bad. That's why it assumes cylinder 3 also bad. To avoid this misclassification, we need to we need to split this one by using other variable. For example, there might be any other variable. For example, cylinders, price or any variable. By using that variable, we need to split this one to predict whether it is bad or good correctly. So categorical variable K factors in how many ways you can split data into binary sets. Here, see how many classes are there. You can split that many binary classes. Here, how many classes is there? 1, 2, 3, 4, 5. 5. So you have to split 5 classes. K, if we restrict split points to be K equal T and K not equal T. Why? Because if you restrict it, that's what I said. If you restrict it, for example, instead of taking these 5, if you have to split it 3 points or 2 points, what will happen? Some information we will lose. What will happen? Some information we will lose. That's why go can do better, sort the attributes, find all breakpoints. That means, let's take these are here. Green is the good, red is the bad. So we need to split all cylinders 0, 1, 2, 3 by sorting. Sort first what they said, sort the attributes. That means attributes. For example, 3, 4, 5, 6, 8 like this. Sort. Then after find all breakpoints. Here this is the good. Here one breakpoint. Here this is the again started bad. So one breakpoint. Here again it started the good. Again you can split here. Wherever the class changes, at that point you can put one split. Then through whenever we go through this split, we will able to classify correctly. If you are not splitting exactly, what will happen whenever new data point comes? For example, let's take it is the categorical data. Let's come to the numerical data. For example, here same process. Sort the attributes that you can split and find all breakpoints. Consider the split points. Let's take here we have the 0 to 5. Let's take 0, 1, 2, 3, 4, 5, 6, 7 like that. Okay. Here you have split here. If whether new data point comes, it is 0.25 or 0.15, what will say? It is the bad. Why? Because that point belongs between these 2 points. This is the 0, this is the 1. We consider like that. That 0.15, 0.25, those are comes less than this one. So we say whether it is a new data point comes 2.8, 2.3, 2.6, we'll say it is the bad. Let's consider we have taken same example. What I have here, what I said here. See, instead of taking breakpoints like that, you have taken only one breakpoint, that is the greater than or less than. What will happen? If same thing you can apply here, you have take one breakpoint. If it is the less than, that is the good. If it is the greater than, that is the bad. What will happen? There are some bad points on the less than side. Whenever new data point comes with this type of data, what we'll say? We'll say this is the good. Why? Because we have taken only one breakpoint. Due to that, it is the less than the threshold value. That's why we are saying this is the good, but the data point is belongs to bad. To avoid that type of breakpoints, that type of splitting, we need to sort all values. Whenever class changes, we need to break that point. For example, we'll take one. Let's take let's take this is the personal loan. Zeros 1. This is the family. 1, 2, 1, 3, 4. 1, 2, 3, 4. What we'll do? First we'll sort these values. 1, 2, 3, 4. Like this. Let's observe. 1 is belongs to class 0 or class 1. So 1 have the both class 1, class 0. What we'll do for the 1? We need to 1 have the class 0, class 1 both. That's why first we need to consider 1. Let's take this is the root attribute. Root attribute is whichever have the two classes, we'll take that one. Okay, let's take the family. 1, 3, 1, 2, 3, 4 are the 4 splits. Again, 1 have the personal loan 0 and 1. What we'll do? For the family 1, we again split through the CCVG. For the 1 low, 1 high, 1 C. For the 1 CCVG low, that is the personal loan 0. Okay. For the 1, if the CCVG high or medium, that is the class 1. So by using family 1 attribute, we can't able to split whether it is the personal loan and 1. But by using these two splits, we are able to split whether it is the personal loan 0 or 1. Yes, guys, just you can understand this one. First, we have splitted family. It have the 5 variations. So 5 splits. 1, 2, 3, 4. Let's take 1 is belongs to class 1, personal loan 1, 0 or 1. We can't say by using. Why? Because 1 is assigned to the 0 and 1 is assigned to the 1. At that time, what we need to do, we'll take CC average is the split for the 1 again. Another split. Let's check CC average is low or high and medium. If family 1 and CC average is low, that is the personal loan. If the family is 1 but CC average is high and medium, that is 1. That is 1. Same is applicable for the 2, 3, 4. So we need to split each and every data point. You can't split binary. That is what I said, distinct data points. Here we won't split binary splits. We will do the distinct splits. How many variations presented in the independent variable, that many splits. Okay?
Yes, ma'am.
Yeah. If it is the categorical data, that's why we have the 4 classes. That's why we have split it 4. Let's come to the numerical data. Numerical data, actually, there might be lot of values. There might be here only, these are all are categorical. Let's take 4, 3 distinct values. Coming to the ID, how many distinct values? 13. If we have taken these 13 splits, what will happen? Whenever new data point comes, if that data point doesn't have these 13 values, that data point have the other value. Shall we able to split whether it is a personal loan 0 or 1? No. Why? Because the data point information we don't have. Yes, the data point information we don't have. What we need to do? First, we need to sort ID 0 to 48. Then after, we need to check the ID 1 to 6. We will take one breakpoint here. So again, actually it have the only classification. Let's take the first example here. This is also, we have the, this is the numerical data, this one. You can arrange this one, sort by ascending order. 60, 70, 80, 85, sorry, 75, 85, 90, 95, 100, 120, 125, 220. We are sorting like this. Based on this dependent variable, we need to put breakpoint. How do we put? Let's check. 60, no. 70, no. 75, no. 85, yes. So what we'll do? After 60, 70, 75, we'll take one split. We'll take one split. Then after 85, 95, 90. 85, 90, 95. Both all are yeses. Coming to the 100. 100 is no. So here class again changed. So again you will take one breakpoint at the place 95. Again check 100, 125. Both are no. 120, no. 220, no. So after 220 again we'll put the one breakpoint. So base depends on the class value. We will split our numerical data. Okay?
Yes, ma'am.
Yeah. What will take here? Greater than 60 and less than 85. This is the one breakpoint. Greater than 85, greater than or equal to 85, less than or equal to 95. That is another split. Greater than 95, less than or equal to 220. That is the another split. We'll take splits for the numerical data like that. Okay. For the classification, we'll take the single, married, and divorced. But coming to the numerical data, there might be a chance of, see, all are different. There is no value repeated. So we can't take like this. We'll take like that one. We'll check whether the 60, 70, and 85. Sorry, 60, 70. That's it. 2 points. 75. So we'll take within one split 60 to 75. Another split 85 to 95. Another split greater than 100. Okay. This gain ratio is the final metric we will take we will consider to select or to identify the root attribute. Are you people understand where gain fails? Gain gives high value for the if the data in attribute have the high variation. If ID have
Yes.
the high variation compared to CC average, that's why gain we got the high entropy, high gain for this ID value. But
Mhm.
for CC average, we are getting the less gain and less entropy. So for that purpose, what we'll do to avoid this type of problems, we are calculating the gain ratio. Gain ratio. What is the formula for the gain ratio? Information gain by information content. So how to split categorical data, how to split numerical data.
Mhm.
These are the some applications of the decision tree. Sorry, this is the some through the machine learning model, how we go. These are the some steps. First, a decision tree is a tree-like structure where each internal node represent a decision based on the specific feature. So, for example, what it says, it is the tree-based structure. Here in this node, it says about the one independent variable. Coming to the another branch, it says the another attribute, that is the independent variable. Go for the another branch, it says about the some other independent variable. Here it consider some other independent variable. That is the tree structure. Each leaf node represent outcome of the prediction of the algorithm. So here, sorry, each internal node represent a decision based of the specific feature. Specific feature is nothing but specific independent variable. Feature, independent variable, attributes, all are synonyms. That's it. For the independent variables, there are a lot of names that are the features, predictors, attributes we will call. So, splitting criteria. That is the algorithm selects the best features to split the data at each node. The goal is to find features that best separate the data into different classes or minimize the variation, that is the variance, for the regression tasks. Common splitting criteria include Gini impurity for classification and mean squared error for the regression. For the regression, always mean squared error. Here, this algorithm selects the best feature. How do it select best feature for split? By calculating the gain ratio. By
Okay.
calculating the gain ratio, it will select what is the root value, root feature, what is the leaf features.
Mhm.
Don't think we are calculating gain ratio for only selecting root. After selecting root, again we calculate the gain ratio for the each independent one to select the leaf node. For the root variable, we need to select other independent feature, independent variable for the leaf. Then after, again, base first it will calculate the gain ratio. Then after it will sort which one have the high gain ratio, that is the first root value. Which one have the second gain ratio, it gives the second split. It will use that independent variable for the split. That is the splitting criteria. Recursive splitting. The process of finding best split is recursive, continuous until the stopping condition is met. It will repeat this type of split till we achieve we are able to form one split criteria to achieve to classify the classes correctly. But here we need to take decision making. Once decision tree is built, making predictions is straightforward. New data is passed down the tree and at each node, the decision is made based on the feature values until leaf node is reached. But the output from the corresponding leaf classification regression. Here, decision making means, let's take, you people have the remember hierarchical clustering.
Yes, ma'am.
In hierarchical clustering, first we'll take the entire data set into one cluster. Then after we'll do clusters till each data point comes under the one cluster.
Yes.
Okay. If we have taken that is the path, if is there any value uh, which is not presented in the data set, we got the new data point. What will happen? We are failed to identify whether it is class 0 or class 1. For that purpose, we need to take decision where to stop this splitting. Where to stop. For example, we have the 100 data independent variables. If we use it, those 100 data independent variables to split the classification, it will become overfitting. That means if the new data point have same information, we will fit correctly. We will predict correctly. If the new data point have any variation compared to training data point, at that time it might be fails to predict the correct value. So we need to take decision based on the feature values until leaf node is reached. Where we need to reach the output from the corresponding leaf node is predicted class for classification or predicted value for the regression. At which, for example, let's take the same branch. We need to consider at which branch we are able to classify, we are able to regrade correct value. Okay, if we have, let's take same thing. If we have, this is the split point, whenever new data point comes here like this, we are not able to say whether it is the chi or not. That's why we need to take correct leaf node, through which leaf node we are able to classify correctly that branch. That is the decision making. Then after handling categorical and numerical features, I already explained how to handle the categorical data, how to handle numerical data. Pruning, that is the decision tree can easily overfit. Why? Because it it gives the one tree for the starting to ending. Whenever if there is a new data point have the any new data which is not presented in the training data set, this way, for example, let's take we have the, this is the destination, this is the source. Let's take this is a tree structure. This word is the source. This is the destination. We have created one tree, that is, this is the one way to reach this one. This is the one way to reach this one. This is the another way to reach this one. These are the three routes. Three routes. So we are saying these are the through the decision tree. These are the three routes. Whenever new data point, if it by mistakenly if it go crossly like this, what will happen? We can't say where is the new, where is the destination. Is there any new data comes, we will get confused to go to the to reach the destination. That is same thing happened through the decision tree. It might whenever it gives the high accuracy for the training data. Why? Because uh, we are using same data. We are splitting the data to train to test. So test data also belongs to the train data. All are belongs to same data set. That's why it gives the high accuracy for the training data. Whenever new data point comes, if the test data have any new information, it will gives the less accuracy for the test data. So this is the one drawback for the decision tree. To overcome this overfitting, a technique called pruning is often used. Pruning involves removing branches that do not contribute significantly improving the model performance. That's what I'm saying. That is the comes under the decision making. In hierarchical clustering, we need to break dendrogram. For example, based on the dendrogram diagram, we will split, we will break the dendrogram for the 4 clusters or 6 clusters based on the node points. But if we have taken till leaf node, end of the one, there might be how many data points are there, that many clusters are there. So this is not what customer expecting. So here pruning, it will cut the decision tree where we are able to classify exactly. It will don't go for the each and every leaf. It will cut the branch where we are able to achieve model performance is the good accuracy on the unseen data.
Okay.
That is the pruning process. Here, uh, advantages and disadvantages of decision tree. Easy to understand and interpret due to their visual representation. So it is the tree structure. So due to that visual representation, it is easy to understand. Can handle both numerical and categorical data. So we are able to split using whether it is the categorical data and numerical data. So here we are able to consider uh, if the data is categorical, if the data is in numerical. If the data have both categorical and numerical, we can handle by using this splitting method. Require little data pre-processing like normalization or scaling. This is for each and every model. It is better before going to build model to do the normalization and scaling. Main advantage is can capture non-linear relationships in the data. Linear regression only able to build model for the linear data only if the linearity present in the data. If the non-linearity present in the data, at that time linear regression won't be useful. At that point of view also this decision tree will work. How? Instead of doing one split, it will do another splits also. To go this one. See here, it splits like this. It will
Okay.
be useful for the both classification regression. But coming to the disadvantage, prone to overfitting, especially with deep trees. To that is the decision make where we need to stop this splitting. We need to identify that one. That is the problem here. Can be sensitive for the small variations in the data. If is there any small variation, what will do? It again splits in that variation. In that variation, is there any, for example, if class greater than 80, we are saying something. If is there anything 80 to 85, we have taken greater than 80, less than 80. If we get 80, what will happen? We will fail to say whether it is the class 0 or class 1. That type of small variations will be effects. May not always produce the most accurate predictions. Difficult to handle data with complex relationships. That means ID, take the ID. If we have that type of high variation, it is very complex to identify the to classify the classes and to predict the regression values. Okay, guys, do you have any doubts?
Uh, no, ma'am, not right now. We'll go and have some, we'll read by ourselves, and then if we'll have, then we'll